We're rolling.
All right. Good morning, everybody. Glad to see everyone's still awake somehow. I need more caffeine personally. But, this talk is essentially going to go over how I created a DNS honeypot infrastructure and how that was abused to become part of a DDoS on multiple occasions. We'll kind of get into statistics there and all that fun stuff. Just a warning, there's a lot of bad jokes ahead for about the next half hour-ish. There's a lot of gifs. You'll realize my maturity level is actually quite low. So, who am I? My name is Cody Sm. I am, the best way to put it is I do operational security for a regional internet service provider. In that role, I do network-based security, and I also act as the DNS hostmaster. Roughly 5,000 zones are served on my servers every day. So that makes for fun times. I prefer Mac OS, day-to-day drivers, right? Sorry, Windows guys, just can't stand it. Big FreeBSD guy. And then we can talk about my love for toe-break switches and mechanical keyboard. We can argue that it's not really a mechanical keyboard because it's still a rubber dome, but we won't get into that right now. And I really prefer a good fettuccine Alfredo. So, that's kind of the work version of me. In my spare time, I'm a volunteer fireman, so I run into burning buildings in my spare time. It's kind of a cool little thing I do. And it kind of gets me away from a computer screen every now and again. So, first we need just a little bit of background if you don't know what a distributed denial of service attack is, or just a denial of service attack. Often what this is just an attempt by an attacker to overwhelm the technology resources of a business, person, company, what have you. These attacks often utilize two things. There's normally the type of the attack and then the botnet the attack is launched from. If you move away from a distributed denial of service attack and just go to a standard denial of service, a single host, you don't really need that botnet, you just need that attack vector. We'll kind of get into that here in a second. Often, attackers launch DDoS attacks for reasons such as an online argument. So this used to be more popular back in the days when IRC was more popular, right? You would say something unscrupulous, and then sure enough, you would get dropped off. A more recent one and kind of an interesting one. So Xbox Live, Steam, PlayStation Network, they leak your IP address pretty easily. So a common theme we see is if you're winning, it's very easy for you to get DDoS. Or if you say unscrupulous things there as well, that's a pretty popular one. And now we've also seen, of course, DDoS attacks become part of political discourse as well. There's more than enough articles, videos, news articles, things like that to do that as well. We're going to focus on two different types of DDoS attacks. We're not really going to focus on one killing each other. So there's the application level attack, right? So application level attacks is when you're flooding a web server, say, with HTTP GET requests or posts or what have you, and it just overwhelms that web server, right? You're not flooding the NIC, you're not overloading the firewall, you're not doing anything crazy there. You are simply abusing that one application on the server. And that, traditionally speaking, you may not need a botnet for, right? Depending on how the server is configured, especially when you started using IIS, if it's configured incorrectly, it can be rather easy to overwhelm that server with a very basic set of requests. What we're actually going to focus on is the network level attacks. So these are the two that everybody is very, very familiar with. There's the volumetric attacks. So these are attacks that rely purely on the size of the attack, right? You have a gig pipe in your business, you're going to get a 10 gig DDoS, the math doesn't check out there, right? And then the next one is a protocol level attack. So opposed to just overwhelming the pipe, let's abuse TCP and all the fun parts of TCP to actually overwhelm your network, right? A more fun thing, when you get into things like a TCP SYN attack, often what fails isn't the web server, often it's the firewall, and we'll get into that here in just a second. So, just as kind of a disclaimer, I've stolen two pictures from Cloudflare, and I've given them credit after this talk. If you're not familiar with a DDoS attack and you want to learn even more about individual types, go to Cloudflare's website. They have a lot of articles, they have a lot of information, they have a lot of stories that they can tell. Go to their website, they're great. Anyways, so a TCP SYN attack, right? So if you spoof that first packet, that handshake there, that target wants to send back a SYN ACK. The problem is it doesn't get anything back from that, right? So SYN ACK. So the issue, if you don't have your timeout set correctly, this target's going to hold on, saying, hey, I sent that SYN ACK out. Where's my reply? And it'll just hang there. Right. So Microsoft's iOS, I think the default is something rather normal. However, some web servers and web administrators like to lengthen that timeout so their users don't get disconnects. But another issue where you really start to see this crop up as a problem is often, if you have a stateful firewall that's keeping track of this sort of thing, a stateful firewall has to keep track of all these TCP SYNs coming in as well. Well, the problem is it's used to keeping track of however many connections, and you're doubling and tripling that. Often, when you're buying a firewall for your business, you're speccing it out based off the bandwidth that it can do, right? So you're looking at saying, hey, I have a 100 megabits per second connection from Spectrum per second. I really, will never need more than a firewall that can really do 100 megs, whatever, right? Most of your firewalls now are a gig anyways, but just play along. The issue here is those vendors don't tell you how many connections it can keep state with, and if they do, they're not truthful. That's why it's very helpful to say, hey, I really want to buy your firewall product. It's really, really awesome. However, can you have it for like a month, just to play with it, throw it back on the bench, and just run a lot of packets through it, right? See what it'll actually do. Because normally, what's purported and what's real doesn't normally line up. So this is a TCP SYN attack. I needed to get kind of the protocol abuse attack in here somehow. So we're just kind of getting it out of the way now. So, hey, I thought this talk was about DNS. You promised DNS. I was ready to be abused for half an hour about DNS. The volumetric attacks. I needed a GIF for this slide, but I couldn't find one about DNS. Shockingly, there isn't one. So I just figured 2 cats would be good enough. Anyways, so the host machine, right, has multiple slave sources, right? This is where your quote-unquote botnet comes in example, or you can just do this off your laptop if you're bored in the back. You send this very small request to a DNS server, and for example, what you can do is you can dig for the isc.org zone file. Because it's ISC zone file, there is a lot of cruft in that zone file on purpose to show off what you can do with something like mine. And what you do is you say, give me any record you have for the zone back. The issue is that's a rather large response. You're talking an implication vector of 100 to 1,000 times what you sent, right? So it was a very minuscule packet going out, but the answer you got back was rather large. Often, this is over what your default allowed packet size is, so these packets are now fragmented. If you go look at Cloudflare statistics or what we have seen, what you'll normally see is that IP fragmentation normally either doubles or triples the actual protocol that you'll see come into a network during a DDoS attack. Right? So just because you're only getting 2 gigs of DNS traffic, if you move away from that DNS traffic and you look at the IP fragmentation, you're getting extra 4 to 6 on top of that. Right? So how this really works is you're having your hosts that are in areas that ISPs allow spoof traffic to come in. The problem is we'll never solve that no spoof traffic thing. There are certain countries that have vested interests in allowing spoof traffic. You can figure that out. So because they're sending these spoof requests to this DNS server, the DNS server then says, oh, you want everything on the menu. Well, here it is. Well, it'd be like if I walked up to you and gave you everything on McDonald's menu. You'd be very confused all of a sudden. Well, this is awesome, but I'm not going to eat all this food. Right? The problem is, with one packet, with one request, that's fine. But if you're multiplying that times 10,000, 20,000, 30,000 hosts, you have a real issue on your hands, right? So, again, stolen from Cloudflare, shamelessly, right? Definitely link them here. This just kind of shows, look, this, the botnet, it also doesn't have to abuse just one resolver, right? It's not a 1-to-1 ratio. Often, these bots are sending it to various DNS resolvers. So that's the interesting thing. Is if you go look at the traffic from a DDoS attack, what you're seeing, you're not seeing traffic from these bots. You're seeing the traffic from the actual resolver themselves, right? So if you go, take your list of all the hosts that attacked your business during a DNS amplification attack, and you go, drop that list into Shodan or what have you. Did a talk about Shodan last year, or using Shodan a little bit last year. You go look, and they all have port 53 open. Well, you go query, just google.com against these. and they all return an answer. It's like, oh, they're all open resolvers. Awesome, this is a problem we've had since what, the mid-90s? That's like when I was born, so I'm speaking out of turn, but, right, this has been a problem since a very early part of the internet, right? You've commonly heard people preaching, hey, by the way, last year I did the same thing, where the name didn't match the picture, but I had done it with something like very unscrupulous, like, I think I did Thomas Edison, but I had Tesla's picture, and someone came up after the talk and they were like, no, that wasn't Thomas Edison, right? You missed the entire point of the slide then. So why are we talking about this? Why are we talking about DDoSes and DNS application-based DDoSes? Well, one night, late at home, listening to probably some random jazz music in the background, I was playing around with AWS. Obviously, AWS is very, prevalent in the information security space, so it's always good to have a handle on what's coming up. I prefer DigitalOcean, but I understand for business use cases, that's not always the best application, right? AWS is really winning that business market. So, playing around with that, I wanted to play around with AWS CLI a little bit more. The CLI is very powerful, allows you to do a lot of things very quickly, and you can mess things up very quickly too, just saying. So I scripted the creation of a VPC using AWS CLI, right? Now when I say a VPC, I don't mean just the one command that just creates the VPC in the virtual private cloud. I mean the ACLs, security groups for all of this, the keys you need, cloning the EC2 instance, making sure everything's got the DNS records, all of it, right? I wanted to just click VPC, right? The issue is, this took the input of a file and it said, hey, create the VPC in this availability zone. And it was just a while read line, hey, whatever availability zone I give you, create a VPC, right? The use case here is that if you have a business and you instantly want to spin up a VPC for your business's website, every availability zone Amazon has, you can just feed it that, right? The issue, 2 a.m. Cody is not smart Cody. Arguably, like noon Cody is also not smart Cody, so I don't know why you guys are listening to me talk right now, but like, yikes. Anyways, what it should have looked like, it should have just had US East to it. Instead, I had all the US availability zones in it, so I created 4 servers, which is no big deal, right? So what, 4 servers? Nobody cares, it's just annoying that I have to delete all these things. But now, in theory, I have a server, pretty much in every little quadrant of the US, right, in theory. What if I turn all of these into DNS servers, right? That'd be really cool, it'd be really easy. They're all running FreeBSD, so I'm comfortable with it. So literally all I have to do is just package, install, unbound on all of them, set up the configuration file, make sure everything's good to go, and bang, I'm now running 4 DNS servers. Simple enough. Everything was easy. If you're into DNS and you're still using bind for a recursive resolver, I would have you plan to unbound very quickly. Just FYI. So, anyways, set up a default configuration with heavy logging. This is logging I wouldn't normally turn on, especially if I was running a business, right? Because you get to see the queries that are being made, right? I find that to be very unscrupulous. Not something I'd like to do. Anyways, so all of a sudden, you have 4 DNS servers. They're running throughout the internet. Who cares? However, I didn't want to go look at all of these. So, 2 things. Spun up an ELK server in DigitalOcean, that way I could ingest all these logs that my DNS servers are picking out, because there are quite a few of them. And at the same time, we all like pretty pictures, so using a Raspberry Pi in my home office, I just made sure I can keep my Grafana dashboard because it looks cool, right? I don't know what kind of friends I have over that they would think that is cool too, but like, anyways, it's just a pretty picture in my office. However, the graphs weren't busy enough, the logs weren't busy enough for my musings, right? So, I just doubled everything. So I made the script say, hey, if this already exists, doesn't matter, create a second VPC using the rules from the first, everything's simple, right? Essentially just cloning what we had the first time. Right? So now we're only 8 servers, not a big network, right? Nothing crazy. Eventually this grew to 12, but I didn't like the bill I got from Amazon, so I scaled back to 8 again. Again, so these are all just FreeBSD 11. They're all forwarding queries to either Google's primary or secondary server. That way I don't have to actually serve the requests, right? But nonetheless, I can see all the queries that are being made. Excuse me. So the interesting thing is if you look at the logs and you look at the Grafana dashboard, you can see 2 different things. You can correlate spikes in the DNS queries and the bandwidth usage on these EC2 instances to when they were definitely being used. Now, what were they being used for? often they were just being scanned. And funny enough, if you go run reverse DNS on the things that are scanning you, often it was either ISC or Berkeley. I don't know why Berkeley was so interested in everybody's name servers for a while, but it was definitely a couple-month period of time there where seemingly every day they were scanning. And then other actors, right? Everybody's scanning the internet. Everybody wants to know what's out there. Showdown's crawling the entire thing, right? It's just something that happens. Welcome to the internet. It was used as a resolver by my own side projects, right? I had 8 DNS servers and I had a lot of little side projects that I was bored with, so let's just point them there and make sure everything's still working. Right? Makes sense. And then used in a DDoS attack. So it was kind of one of those, if you build it, they will come. I had the assumption that if I put 80 servers out there, eventually one would be used in a DDoS attack. Or that was my goal. Sorry. So after they were on the internet for a short period of time, they really just got scanned, and I was kind of bored with the project. There started to be little spikes in queries and bandwidth usage at the same time. And if you went and looked at the logs and looked at these queries, they were for the same zone, the same record type, and they were typically from the same source IP address. Right? Often, for normal traffic, you don't need to query for the same zone again and again and again and again, and you're certainly not querying from ISC's zone file with any record type again and again and again for normal traffic, right? That's just not something that happens. If that is your workflow, I have a lot of questions about what you're doing in your spare time, and I'd really like to talk to you. But anyways, so often these spikes in bandwidth and queries only lasted, 5 or 10 minutes, which is working there. Often they only lasted 5 or 10 minutes. They were relatively brief, but they were very aggressive spikes in queries per second. They were very aggressive spikes in bandwidth. I was seeing roughly from, no bandwidth usage to roughly about a megabit per second in to about 10 to 15 out, right? Which again, doesn't seem like a lot, but when you times this by 100 servers, 3 times this by 1,000, that's going to get rather aggressive after a while, right? So, anyways, if you looked, you could replicate the queries that were being created by running a dig against one of my servers, which they were honeypots, so of course I named them after Winnie the Pooh. It's a logical thing to do, like an adult. And this is really what it was like. And if you went and ran this without the web server there, because I took the entire thing down before the talk, because I think that would be immature to just leave a bunch of web servers up and speak about them in a talk. It seems kind of ill-advised. Anyways, so if you dig this, say, Google's IP address, the 8.8.8.8, and then ask for any record type, you can see the very large answer you get. And most of the time, unless you specify ignore, it will send you a truncated response back by a TCP opposed to that UDP response back. That's how large the query is, right? It says, hey, UDP is not the best option for this. We really need to do this over TCP, but you can still force that UDP transfer to happen. So, Pooh was easily the most abused. He was my first EC2 instance out of US East 2. Eeyore was just about the second, which was kind of funny given Eeyore's general demeanor. So, in total, looking at statistics after 1 year of running the project, saw over 300 DDoS attacks. The most prevalent DDoS attack that we saw was over an hour. I shouldn't say we because me and the mouse in my pocket. Was over an hour, and it was the most costly DDoS for me. My bill was the highest it had ever been that month because it was just abused. Anyways, and most of the time it was kind of funny. So the most common times these servers would get hit were during 9 to 5 hours, which doesn't really make sense because people would be DDoSing toward the evening or something like that. But no, it's in that 9 to 5 time range. And of course, because these were DNS servers, we were seeing all UDP and DNS amplification-based attacks. It would make sense for me to run a DNS server and see NTP attacks. I have a lot of questions. So, how are these attacks being launched? Well, if everybody takes pact secrecy, we can show you right now. And you all have that look on your face. I'm going to assume you're all going to keep it a secret, and this is top secret knowledge that nobody knows. And I'm going to trip over this HTML port. Okay, step 1, download Tor. This is an optional step that you don't really have to do. It just looks cool for this slide. Step 2, steal your mom's credit card and buy some Bitcoin. You could use your credit card, but that's a little unscrupulous, so steal your mom's instead, buy Bitcoin. Step 3, zero morals. There's no slide for step 3. Step 4, profit. That's right, you get a free trial for your DDoS attack. 200 megabits per second, which is nothing. But here's a couple of things you should just realize about people that are DDoSing your infrastructure, right? When your infrastructure is DDoSed, say you have an online store, an online web presence, you're losing, you know what, $10 a minute, $100 per minute, $1,000 per minute, right? What's your business model, right? If you're a hospital, can you afford to be offline? Because you probably send out e-scripts, things like that, your patients are going to be upset. If you're in public safety, you know, that's a dispatch center that's down for a while, especially since a lot of you are going to E911 with CAD. Things like that. Can you afford to be down for 300 seconds? Do you have more than a 200 megabit per second pipe? Can your firewall handle the extra 200 megabits per second? Do you have a 500 megabit per second plan through WoW and you're normally at 400? Well, now this 200 megabit per second attack's an issue and it's free, right? The interesting thing is if your attack doesn't work, you can contact the website and they will help you pick one that would have worked better. They do have sales, so Black Friday and Memorial Day, there's a President's Day sale, you know, there's some really cool stuff there. And these are monthly plans, right, for roughly the cost of Netflix before they raise their prices again. You can have a decent DDoS whenever you felt like it. Often these, often these stressor services or booter services, whatever forum you go on to, often these are very cheap attacks. These are $5 or $10 attacks that promise to send 5+ gigabits per second of traffic to your network. Right? Often it's not uncommon to see a 10 gigabit per second attack. They normally use a UDP amplification vector. Some services that are a little bit more expensive and you get up in the $50 to $100 attack range is really when you start to see things like the TCP SYN floods, the application level attacks, similar to what took Dying down in 2016. If anyone remembers that, when Twitter was down for a short period of time there. You can buy a DDoS attack, right? Often it's not the group of people in here sending a DDoS attack for some reason. It's a child that stole his mom's credit card because it's already on his iPhone, and he's trying to get a class for 5 or 10 minutes. Right? Which sounds like it doesn't make sense until you realize that online testing now takes up most of your kid's time. You have a 50-minute class period, you only need to cause a 5-minute disturbance to get out of your test for that period. Right? So even K-12s, who, this nice little land, they still have to worry about a 5-minute internet outage, ruining essentially a day for a teacher. Because if you're a teacher in your first period class, can't take their test, what do you do for the second and third periods? Oh, well, sorry, you have to take your test. Even the first period didn't because the internet didn't work, right? These services come and go, right? The interesting thing and kind of the funny thing is if I said, hey, you need DDoS protection, for your website, you would probably go to Cloudflare. Interestingly enough, if you go do a dig for most of these services that are using, that are offering IP stress test services, guess what DNS servers come back for that website? Cloudflare. Yeah, it's weird. Anyways, so these services come and go. The one that I posted back here, that's been around for a while. I think it's just ipstresstester.com or something like that. Just a quick Google search will get you there. But be careful when you do go to these websites. The joke about Tor was actually quite real. A while ago, back in, I think it was April of last year, kind of the consortia of different countries all came down on one IP stress test service, and they looked into every IP address that visited that website and one of the ones that had an account and made a transaction. And we should disclaimer all of this, right, because I showed an IP stress testing website. Doing anything like an IP stress test against an IP address that you don't have permission to do it against, or one you have access to yourself, that is the Computer Fraud Abuse Act. Definitely, that's a 4th degree felony if I remember correctly. So that's like 30 days in jail, but it's a felony on the record for the rest of your life. So don't do that. But yeah. But why do I care? And the reason why Alex Trebek is up here is because I was going to put some political figure, but I was watching Jeopardy last night, so. Which also says a lot about my Thursday nights. So the reason why anyone in this room would ever care about these DDoS attacks that are happening is because they happen to businesses, right? They happen to educational institutions, they happen to medical institutions, they happen to online businesses, they happen to you because your company, the president of your company has a Twitter for some reason and tweeted some unscrupulous things, and now your social media team can't work for the day because they all got kicked off. Right? So DDoS attacks happen, they're cheap, they're easy to make happen. So, that's why everyone should kind of care about this sort of thing. It's kind of fun to see on the news that, there was terabit per second attack towards GitHub. But, it kind of comes down to you guys. Right? So steps a business can take. If your website's deployed in the cloud, make sure you're at least familiar, if not utilizing that cloud's options. So, for example, I forget Azure's offering, so someone will have to step in there. But for example, AWS has AWS Shield. If you're on-prem, you definitely need to have a talk with your internet service provider about what they do. I know for a fact AT&T and CenturyLink, if you have either of those as provider, do offer a DDoS protection service. Unsure of WoW or Spectrum, just make sure that's in your discussion when you're working with those business contracts. And at the same time, if you're hosting that website on-prem, definitely look at a proxy service similar to Cloudflare, right? Someone that's going to take that data and just kind of distribute it out. If you're unfamiliar, one of the ways Cloudflare, bills itself as working is the fact that they're acting essentially as a constant distribution network at the same time. So because there's so many quote-unquote instances that these DDoS attacks can get to for Cloudflare, it really minimizes the impact. Minimizes. There we go. The impact of your actual website. Right. So that's if it's on-prem. If it's in the cloud, like I said, look at AWS Shield, look at the Azure offering. Make sure you're at least familiar with if you're not using these. And the biggest, word of caution that I can say is, if you're looking at, for example, something like Cloudflare, your website's DNS is what really runs that transition in Cloudflare. So if you have, for example, an 86,400 second DNS time to live on that record, it can take up to 24 hours for this attack to actually go away and Cloudflare to take over completely. Right. So this is really the time that you also need to look at your infrastructure's DNS and look at, hey, what's the expire time of my zones? What's the time to live on your main default, your www record? Right. Is that set to 300 seconds? Is it set to 3,600? What's that set to? How quickly could I change that if we had an issue? Right. And that's something you should look at just as the general best case. So if you have that pointed to a single IP address on-prem, that server just dies. Is it quicker for you just to change that IP address, have a 300-second TTL and back up in 5 minutes? Or is it quicker for you to bring up a new server with the same IP address and all that fun stuff? Right? Which one's better for your use case? So how can you help? Stop running open DNS resolvers, please. Dear God, I don't know why anyone does it except me because I did it for a year. Which really like the pot calling the kettle black here, right? So if you're running a public DNS server, it should only be answering zones that you're authoritative for, right? So if you own BSidesColumbus.com and you're running a DNS server, it should only answer queries for that if you're open to the internet, right? That's how an authoritative DNS server works. You shouldn't be running a recursive or caching server that's open to the internet, unless you just really believe in privacy and that's weird. Billing there, but we can still have to talk about that later. And while we're at it, something else, open NTP servers are slowly dying because no one really uses an NTP server anymore. No one really runs their own NTP server anymore. For example, AWS has their own implementation on the local host. And most other people, especially if you're running Apple, for example, you're using time.apple.com. Windows has their servers that they recommend using, et cetera, right? So that NTP problem is slowly starting to go away. But something you guys have really helped amplify over the past couple years is LDAP. Struck a chord mentally here. So, open LDAP resolvers. The problem is the amplification vector is higher than that of DNS, so it's a more easy attack. At the same time, more people are rolling out LDAP servers that are just open to the internet. The issue is that can be abused, and it can be abused easily. It's the same thing we talked about with DNS, right? You're sending a very small query or a very small packet into this LDAP server, and you're getting back a very, very large return. Normally, the amplification vector higher than that of DNS or NTP, right? So the issue is, this doesn't need to be open to the world normally. Often, if you look at your LDAP implementation, the type of traffic that's occurring here isn't really what you would expect to see for a user authenticating with LDAP, right? Just something to think about, something to look at. And this kind of links back to my talk last year where I discussed, looking at your external posture of your business. You might not know that you have LDAP open to the world. That's something you need to glance at, something you need to look at. And then if the system administrator says, hey, I need that open, have that discussion about why they really need it open. So, just to wrap everything up, I was really quick on time this time. About half an hour is what I expected. So, things to come. I'm going to write all of this up in a blog post because I get rather ranty when I stand up in front of people and do more technical details. There's going to be a GitLab repo. I think I do have Mr. Cody Sm, if I remember correctly, for the GitLab repo. If not, I'll tweet about it too. And that'll have more log examples and things like that. I've never had good experience putting log screenshots up on the screen. It just doesn't work out. Nobody can see it by the time you get to the back of the room, things like that. So I'm just going to post all that up in a GitLab repo so everybody can see. The AWS script will be there if you're curious how this VPC madness came to become, which really, at the end, it was only 8 servers, right? That's nothing to complain about, but it was just kind of like the expected one. I ended up with 4, and then that magically grew up to 12. So the scripts are going to be there, the logs are going to be there, things like that. I'll redact the IP addresses and things like that. That way there's nothing sensitive in there. But just so everybody can see kind of what it looks like with this DNS servers being abused. And then, the final takeaways for me. If you're a business and you've never thought about, what happened if I get DDoS? Think about that before you leave today, right? Especially if you have, like I said, if you have executive leadership or anybody like that that has that, voice on social media like most people do. Often we see when someone is rather unpopular on social media, that business can become victim of cyber attack rather easily, whether it's a DDoS or not. So something to think about there. If you're an e-commerce business and your bottom dollar depends on being online all the time, 24 hours a day, 365 days a year, it might really be to look at something like AWS or Azure where they can offer those levels of protection. And if you're, dead set on staying on-prem, I would very much still recommend looking at Cloudflare, right? I'm obviously not an employee at Cloudflare, but I definitely endorse their product. I've used it for a couple of my personal projects and a couple of little side gigs that I've done with great success. Otherwise, that kind of wraps up everything I have. I don't have any more gifts or anything like that for everyone. So if you have any questions or anything like that, that's kind of what I banked on.
Did you analyze the traffic at all for command and control or exfil stuff? Or did you notice anything in there that would have been?
So where this project started getting a little bit more expensive is I also just TCP dumped the interfaces the entire time because TCP dumper didn't happen, right? Or PCAP didn't happen. I'm sorry. So often during an attack, I would go back and look at the PCAP files for that time period because I just broke everything off in 5-minute chunks, right? It's a little too crazy. And sure enough, what you mentioned, seeing that, right? If you go look, you can see some command and control, not much data exfiltration or things like that. I was definitely, had enough forethought to lock down every port except DNS, right? So you could see things kind of coming in. There were common hosts that were talking to me, but other than that, nothing crazy. And that was just, I knew these things were going to be taking time on, so let's not, let's make sure the SSH isn't open in the world. It's only open to my VPN that I run, right?
Is there a value in having a honeypot system like this for trending, for identifying threat actors, or is a website suddenly dropping off the internet enough of an indication?
For the DDoS thing, right? That's my project line, right? I deal with DDoS as a work, I deal with DNS at work, so bringing that home to play is kind of a nice thing to do. I would argue. If you have the time and the resources, and you have a business that allows you to set up a honeypot infrastructure, that's a very valuable thing to look at, right? That's finally a box that you can TCP dump the interfaces all the time, and then watch for your indicators to come in, right? Especially if hey, nobody should ever log into this box, right? It's a honeypot. It's on the other side of the network. HR doesn't know about it. Accounting doesn't know about it. But nobody should log in this box. And then you see HR's credentials trying to go there. Well, that's an automatic indicator. That's a flag, right? So I find there's great value in putting honeypot on your business network. However, you have to be very, very careful because if you set up honeypot on your business's network and it's not set up properly, and it's not segmented from the network properly, you just open yourself up to a whole new world of hurt. But that's my opinion at least. Your use case is very.
Did you, at any point in this project, get notifications from your VPC provider about, like, hey, you have DNS open?
So, there's a reason I did it.
Okay.
So, young, naive, 22-year-old Cody, which is only a year ago, so right. So, young, naive Cody, when he first spun up a VPC, had this awesome EC2 instance. I was like, oh, I can app install, Nmap, because it was running a bunch of them. And I was like, oh, what happens if I Nmap my house address? 10 minutes later, I got a cease and desist letter from Amazon saying, hey, you're doing bad things. Like, why are you skimming out of this VPC? That's bad. They have a form you can go and fill out and say, hey, I'm going to be doing X, Y, and Z. Please do not contact me about this. I understand what I'm doing. So, interesting if I created an account, ran the server, and see if they'd still tell me about it. But the reason I know I didn't get a notification is because I said, leave me alone. I'm doing security work over here. Here's my credentials, right? I signed up with my student email address at the time that I had, that I still had access to, so I could say, hey, I'm a student, kind of doing security work, security research, things like that. I have a job too, but whatever. And they were, oh, sounds legit to us. And they gave me a double thumbs up and moved on another day. That's a very terrifying email to get at 3:30 in the morning, like a cease and desist letter from Amazon, like, no thank you. Right?
So the second part of the question, mainly the reason I asked, I'm sure you've heard of Pi-hole. So if you check that subreddit, you see a lot of people like, hey, I don't want to host it at my house. I want to do DigitalOcean or something. And immediately the first comment is like, hey, don't do that. But if you want to, here's how you would do it.
Yeah.
So I'm curious, like, as a civilization, if there's anything in place, and you don't have to have the answer to this, but maybe you would have an idea of what we can do to thwart that. Because if people don't know that it's wrong, they'll spin it up and they'll do it, but then you're making a foothold for attackers. So.
Yeah. So the real solution to all of this, and I can't believe I didn't put a slide in, I kind of feel bad now. Some of the older members in the room will definitely remember when the Open Resolver project started to come around, and they really started to hound on people about having Open Resolvers on the internet. That was a very popular thing, because you almost got kind of shamed for having an Open Resolver. It's kind of what you discussed. It's the people in the Pi-hole subreddit going, hey, bad idea. Here's how you would really do it if you wanted to, but we don't suggest it. Right? That's kind of the way to kind of go about that, is the community just kind of has to act as the guardrails there. Otherwise, I really don't know the answer for the second part of that is how do we help the internet at large, right? Other than not contributing to the problem ourselves, like I did for a year. Yeah.
What type of DNS attack was your servers most used for?
Sorry, I mentally blanked there for about a solid second. So the DNS-based attacks that most of my servers were used for, if you looked, we were getting queries for either, I say we, I'm talking about ER2 and I. They were basically used for essentially, like I said, that ISC zone file, dumping any record, trying to get any record back. DEFCON is another one that's kind of hilariously large, and they know it is. So those two attacks are really the ones that we saw the most, if you look at kind of the grand scheme of things. Interestingly enough, though, and I kind of found this interesting, something I wasn't really expecting is I got a lot of queries for MX records for things like Google and what have you. The reason is that MX record type, it's rather large. You normally have 5 or 6 lines of entry, so it's not a huge amplification there, but it's an amplification of enough, right? Nobody said people that were running DDoSes were looking for the most bang for the buck. They might just be looking for a smaller bang for the buck. So I was kind of surprised in that, especially when you get into companies that have DKIM records, so they have a very long text string in the records as well. That kind of adds to that as well. So, was not expecting it, but ended up with a lot of queries for either MX or TXT record types as well.
Cool, thanks.
Any other questions or any fun things like that?
Okay, I'm really new to this. I haven't really looked into much cybersecurity. We're in a networking course for CSYN. I was just wondering if you could clarify what LDAP is, because we're familiar with DNS, but we didn't really get it.
So, LDAP. So, 2 things, right? First off, LDAP is slowly being replaced, and I'll get yelled at by someone in the classroom for saying this, it's slowly being replaced by secure LDAP. It's an authentication that's happening there. If anyone can give an application use type, I'm not familiar, but an application use type that actually uses LDAP every day. Active Directory. Active Directory, thanks. Right.
Oh, that's what happens when you run
Run back on us all day. You don't have to worry about this.
require default.
Yeah. But yeah, so that answers your question.
Yeah.
And then obviously you guys know what the DB is, right? But yeah, so that's kind of the thing there. And the problem is, because people are just spinning out servers that have LDAP open to the world, because they think it's a required evil to have that open, right? And sometimes there is. But often you can scope that back at least a little bit, so it's not used as much. Right? And like I said, secure LDAP is slowly becoming slightly more popular. And there's also TCP there. But any other questions, fun things like that?
Did you see what type of queries people tried to make against? Well, you did. You only had 53 open, but sorry.
Yep.
I didn't see that.
Seen any?
Well, I've asked before I thought it through, but I was asking if you actually saw what queries people tried to make with LDAP, but then I remembered you said
No, because it was only running as a DNS server. I could always flip the script and just spin up to where that was open, and then watch that traffic for a little while and kind of go back.
So did you have any like big breakthroughs, or did you find anything real interesting about these sorts of attacks that the general community didn't already know, or?
No, that's the unfortunate thing, right? Because DNS amplification attacks have been around for so long, and even in TCP and LDAP, I think everybody kind of remembers when UPnP was an issue as well. There was nothing, really glisteringly new here. It was just the shocking realization of like, oh, if you just put this thing up the internet, sure enough, it'll be abused, which we all do anyways.
Yeah.
But yeah, that's kind of the thing there is that, there were really no new meaningful insights, and I hated that about this because I wanted to present a new idea. But really, it's just about bringing awareness. Hey, if you're running an open DNS resolver, we really need to talk about that issue.
Right.
But yeah.
Would having DNS Second Table on those open resolvers assist in being able to mitigate the attacks?
In theory, yes. And that's one of the reasons why DNS Sec was so widely thumped over the head of many people for a while, and it still is that's supposed to aid in that mitigation, right? The issue is you're playing a numbers game there still, right? You're never going to get the thousands upon thousands of hosts that are running open resolvers on the internet to use DNS Sec, right?
Maybe I misunderstand DNS Sec, but isn't that after the fact checking anyway?
Yeah. So, but because you have that checking in play there, in theory, you were going to reduce the ability to
It won't do the amplification.
Yeah. Any other questions?
Sorry, so DNS Sec, though, it's not really authenticating the. If I'm sending, I'm trying to initiate. I'm sending
it's
packets to
authorizing
DNS
what's actually coming.
What's coming back, not what's coming in.
Yep, correct. The point of DNS Sec there is to really validate that data is what it's supposed to be, and it's coming from who it's supposed to come from. Right? Similar to TCP SYN, so graphic.
Right. So it's.
Yeah.
I'm just trying to get through my head how it actually helps prevent this.
Any other questions or any fun things like that? Awesome. If you have any questions, I'll hang around over as a hallway if people are itching to come into the next talk. Otherwise, you'll see me around all day. You can poke fun of me and say how young and I don't know anything. I hear that all the time. All right. Otherwise, thank you guys. I appreciate it.